Assalamualaikum warahmatullahi wabarakatuh. I am Najwa Suhadah binti Ismail. So today I want to present about the post-station concrete. That is my case study as Francisco Public Utilities Commissions. So for contents, I will explain about the introduction, my case study, and the conclusion for this report. Introduction. So for introduction, I will briefly explain the definition of post-tension concrete. Post-tension is done at a project site and require little to no modifications of the same forming system that would be used to construct non-pre-stressed concrete. The system used to post-tension concrete and masonry consists of the pre-stressing steel that is housed inside a duct of sheet which allow the pre-stressing steel to be placed inside the typical job site formworks. At the same time, rebar and other reinforced is placed. Material of post-tension concrete. This material, the important material is three. That is a duct, tendon, and anchor. So for duct, thin-sheet metal pipes with cloth capping are welded overlap seam supply the length of 5 and 6 meter respective are used as a standards. Ducts are connected to each other by an external screw coupling and sealed with PE tape. Plastic duct also available in the market these days, which are watertight, frictionless, and fatigue resistant. So for tendons, the basic element of a post-tension system is called tendon. A post-tensioning tendon is made up of one or more pieces of pre-stressing steel coated with a protective coating and housed inside a duct sheetings. The pre-stressing steel is manicured as per the require of SNTM A416 and typical standard size are 0.50 and 0.60 inches in diameters. So for anchor are used to anchor the tendons into the concrete while termination or joining to tendons. Main function of anchorage is to transfer the stressing force to the concrete once the stressing process is complete. 5 benefits of post-tension concrete. Number 1 is architectural benefit. Post-tension slab has an advantage over other as it makes a very efficient base for floor design with thin slab and columnless space in large span. It provides an architect the freedom work freely with his design. Number 2 is commercial space. Post-tensioning result is a thinning concrete slab, making the available saving in floor-to-floor height available as additional floor. This can provide extra rentable space within the same overall building heights. Number 3 is a reduced dead load. As the post-tension slab have lesser thickness, the quantity of concrete and reinforced use is reduced up to 20 until 30% when compared to conventional concrete slab. Number 4 is structural durability. Post-tension slab should reduce cracking, improving durability, and lowers maintenance costs. The reflections can be controlled by varying the amount of post-tensioning to balance any portion of applied load immediately after stress. Number 5 is popularity. The demands of post-tension slabs throughout the world continues to increase because of the significant benefit for developer, architect, engineer, contractor, and end user. Standard bonded post-tension slab can be designed with regard to specification on post-tension concrete structures that exist in almost all countries. For unbonded post-tension slab, on the other hand, only very few specifications and recommend at present exist. Suitable regulation are cost of preparation in various countries were not corresponding national standards are in existence yet. The FYP recommendation may be applied. Appendix 1 gives a summary of some important specifications either already in existence or in preparation on slide with abundant post-tensioning. The PT flow system is to be designed and specified in according with the document reference in the table of design standard at the beginning of this specification. Specification can see at the appendix 1. So any other standard code or specification mentioned in the body or prefer of this design standardized is to be considered as part of this specification. In addition, all structures should be designed in accordance with all recommendations for material and component manufacturers. And when a conflict arises in the requirement, the specialist PT design is to highlight this conflict and seek clarifications with the current Eurocode standard providing the minimal design requirements. So, this is a case study. The table shows the general information about my case study. Of city and country of San Francisco Public Utility Commission. So, engineering. Seismic engineer is Tipping Ma and structural engineering is Soha engineer. Architect KMD Architects. For a project completion date is June 2012 and the project type is office. Project's gross floor area is 22,500 square feet. So this is a building description. The city and country of San Francisco opened a rigorous building commission for a new administrative building for the San Francisco Public Utility Commission (SFPUC) at 525 Golden Gate Avenue. Situated on the northwest corner of the Civic Center, the recently complete building acts as the defining northwest either to the large urban room formed by the building of the Civic Center. The new 277 and 500 square foot with a 30-story Class A office building was designed to achieve a long-term cost saving to the city by accommodating the San Francisco Public Utility Commission, which previous occupied private sector lease space. The city set high goal for achieving national recognition for leadership in suitable and environmental responsibility building design and 30 years life cycle performance. Of paramount importance from the very onset of the project was to keep in mind the impact that building will have on human performance, along with creating a world-class sustainable building. The designer constantly had the employers in mind in creating the healthiest, most effective and comfortable work environment. Construction process. The innovative post-tension design replaced two structural steel alternatives for these projects. The PT redesign result in significant cost saving over $30 million on the $200 million projects. An innovative of use a post-tension concrete core shear wall is a future. A sustainable showcase that exemplifies post-tension's capabilities to save material, improve seismic resilience, exchange functionally, and speed construction San Francisco Public Utilities Commission headquarters. The entire tendon assembly must meet the requirement of ARCHI 423 and should be manufactured and fabricated by a plant that is certified by a program such as a Post-Station Institute Plan Certifications Program. So for this process, we have a seed process to seed process for post tensions concrete. So, sustainable considerations. With the goal of improving sustainability and the city of San Francisco's goals to become a zero-emission city by 2030, the SFPUC is implementing a number of projects in all of its core business, that is water, power, and civil. Safety and healthy. They are engineering problems related to post-station operation that affect the safety of employees during work. There are some security checks required before the post-station activity for this project. In addition to checking the equipment used regularly during work, there are also important checks to be taken to ensure employee safety and material quality. There is have a egg safety and healthy that provide for this project. Challenge during this project. During the planning process of this project, there were several challenges that need to be addressed. The original SFPUC plan called for base isolation to fulfill the performance requirement on the 12-story building. However, owing to the budget constraint, that plan has to be shielded in favor of a system of steel moment frame with freckles temper. However, the cost was still too high, approximately $62 million, more than the $133 million budgets to cost effectively meet the performance mandate. The engineer proceed to redesign the structure using a vertically post-tension concrete shield wall system with a composite link beam. The resulting solution meet three important challenges. That is immediately the occupancy performance, negligible cost over conventional designs, use of floor and column grid set during design development. In short, the PT shield wall system redesign allowed the of a shorter 8-year-old project to finally proceed to completion. San Francisco's Public Utilities Commission headquarters. Conclusion, the post-tension technology has developed gradually, reflecting the characteristics construction site over the last decade and is expanding in application. In the near future, a post-tension technology will be one of the most competitive solutions for curtain limited circumstances in every country. This paper could promote exchange of ideas for sustainable development of post-tension technology.